Welcome to myprojectbazaar.com.
Now we discuss about a hybrid particle swarm optimization based fuzzy expert system for the diagnosis of coronary artery diseases. Here we analyze the 13 risk factor. It is taken from the traditional approaches and that variables to classify for find the heart diseases in our process. Here a new hybrid intelligence modeling scheme to obtain the different sets of explanatory variables, and the proposed hybrid modelers effectively classify heart diseases. The proposed hybrid models consist of CLBSO with fuzzy interference system. The heart disease is one of the major diseases in the developing world. Here there are six like deaths is possible by the coronary diseases. The system is designed based on the Hungarian Institute of Cardiology. Here the dataset is getting from the Hungarian Institute of Cardiology. The datasets are the part of the collections of University of California. The database contains 7 attributes. However, all the published experiments refer to 13 of them as inputs and the 1 attribute as a result. The input variables are age, blood pressure, serum cholesterol, maximum heart rate, sex and chest pain type, fasting blood sugar, resting ECG, exercise induced angina, old peak slope, fluoroscopy and thallium scan. The output variable is angiographic status. Here the dataset were first assigned by the decision tree algorithm because some of the variable will be removed or the is 0. So that reason that value will be not recognition. So that the decision tree algorithm will be getting the 13 attributes at very well accuracy, and that is for the data mining process for retrieve the dataset from the text format. After the decision tree algorithm, then we use the fuzzy interface system for classify the 30 attributes and find whether the given input database is the disease or non-diseases or else abnormal or normal. Here the fuzzy interface system will be optimized by the CLBSO and for maintain the or improve the accuracy of the classification of the fuzzy interface system. The CLBSO is one of the best algorithm for the optimization process. Here the CLBSO optimize the fuzzy interface rules and it will be generate the new rule based on the input variable or optimization variable of CLBSO. After the optimization of fuzzy interface system, the new rule will be generated. That new rule will help to improve the pure classification of find the abnormal and normal in cardiology diseases. And it is the flow diagram for our proposed work. Here input data will be getting and use the decision tree algorithm for data mining the input data, and it will be arrange the 13 attributes for the classification system, and then the fuzzy interface rule will be generated first as, and then it will be tuned by CLBSO algorithm, and that algorithm will be tuned the fuzzy for the classification, and that fuzzy rule will be go to the classifier, and the classifier will be classify the data set based on the fuzzy rule, and it will be give the result whether of the given input data is the normal or abnormal. Now we see to demo of our process. Open the MATLAB source code and then right click the main.m and run the file, and then the process guide will be open. Load the dataset from the input image. Here I choose the dataset from the input image to the database, and here the 13 attributes will be shown. Here the age of the person is 41 and he is the male peasant, and it is just pen type is 2, the blood pressure is 130 and the serum cholesterol is 204 and plastic plus sugar is 0 and resting age is 2, maximum hot is 172 and extruded induced angina it is not there and old peak is 1.4 and slope is 1 and fluoroscopy is not there and the thallium scan is 3 and the 0 and 1 will be represent it is there or not and the number will be shown that different types of what type of thallium scan will be used and after the details of patient sick load the database and then we use the CLPSO for optimization the fuzzy rule and here the optimization process will be done from the CLPSO. Here it will be checking the all 13 weight attributes and then map the new rule based on the optimization result. And it is the new rule after the classification and it is the each membership function first after the optimization result. The new fuzzy rule will be generated based on this optimization result. And then it is the graph of all membership function and it is the membership function after optimization and it is the membership function of before optimization. Here the membership function will be little bit changing after the optimization. It is the optimization result of CLBSO and it is the initial value of fuzzy rule and then we going to identify whether our input data will be the normal or abnormal. It will be checking our input, this is the abnormal database, so the patient 6 will be getting the cardiac diseases. Then we go to analysis the result and the accuracy of the proposed system is 95% and the sensitivity of the proposed system is 0.9 and the specificity of the proposed system is 1 and the error rate of the proposed system is 0.05 and it is the ROC curve of our proposed system accuracy and that result will be so our output process will be improve the accuracy because the CLBSO will be optimization of our fuzzy rule. So the particular attribute will be taken for the classification process. So the sensitivity of the classifier will be low but the accuracy of the process will be high because the difference between the 13 attributes will be the long range because of the optimization of the rule. So the output will be classified at the high level accuracy. Thank you.